So all of you, please look here. Cyclic redundancy code. So we'll have a quick introduction of the cyclic redundancy code, and then we will see an example of it. Fine. So what is a cyclic redundancy code? So we have some data, right? Now that data is divided with a divisor, and then we get a CRC bit. So when we transmit a data with CRC bit. And again at the receiver end also, whenever we receive a data, the data will be divided with the same divisor, and if we get a remainder as a 0, then accept the data. If the remainder is non-zero, then reject the data directly. This is just a error detection code. Fine. So we will be only detect if there is an error in the data, right? So what happens is over here is, so we have data. Fine. This is my data. Correct. We have divisor, some divisor, and what we have to do is data plus extra zeros, right? See, you can see over here some data is appended with some extra zeros. Now what are these extra zeros? The number of zeros is 1 less than the number or bits in the divisor. Understood all of you? So number of zeros which I am appending here is 1 less than number or bits in the divisor. So कितने bits है अभी divisor में? 4 bits है. Correct? So how many zeros are we supposed to append here at the data? We need to append 3 zeros over here. Understood all of you? I hope this is clear with every one of you. Now we will move to the example. A real we will solve example for us. Correct? So let me start. Okay. So this is my live board. Correct? So we will solve one example directly with us. So first start drawing the things. Okay, I am selecting this. I hope you all are also having a notebook and pen with you. So what I need is a division symbol, correct? So here is my division method. Fine. Now write down the data, correct? All of you please open your notebooks and write down the data with me. Fine. So data is 1, 0, 1. So this is my data, correct? So this is my data word. Now my divisor. So divisor may be given to you in exam directly, or they may give you a polynomial. So I will show you how to take the divisor from a polynomial. So first now I have a direct divisor with me. So my divisor is 1, 0, 1 and 1. Fine. So this is my divisor. Now what is the next step? What I said in the PPT, I hope my screen is visible to all of you. We need to add some redundant bit at the end of the data. Correct? Now how many bits? What are those bits? Those bits are 0. How many zeros are we supposed to add? We are supposed to add number of 0 bits which are equal to 1 less than the length of the divisor. So now tell me, what is the length of a divisor over here? The length of a divisor is 4 because we have 4 bits here. So how many zeros we will add? 1 less than 4. That is 3 zeros we will be adding here. Correct? So here again you can come and then add this 3 zeros. 1, 2 and 3. Correct? So my data is ready now. Now we will do just a simple division. Correct? A binary division we will be doing. So what we are supposed to do in a binary division? Again, take this. So I will be writing my divisor here 1, 0, 1 and 1. Correct? This is what I have written. Okay. So what is my answer? Right. Sorry, I'm so sorry. Some problem I did. Okay. Correct. Now I selected this. Okay. So 1 plus 1, what will happen? It's a binary division. So 1 plus 1 will come as 0. Correct? 1 divided by 0 means 1 minus 0 or something like that. It's a binary division, right? So it comes 1. 1 0, it comes 1. Then 1 1 will give us 0. Correct? So this is what I received the answer. At the same moment, I will start writing the answer also here. So it's 1, correct? Now what am I supposed to do? I will be taking my divisor again over here. So it's 1. I hope you all are doing the division with me. 1, 1 and 1, correct? So what is the answer for this? Fine. Do this and then start.
110.
Yes, yes, yes. I will write the answer. So just a second, sorry. Okay, so 0 1 is, okay, I'm so sorry. We have written it wrongly over here. Are you getting this? What is wrong over here? Anybody understood what I did wrong here? I am not supposed to, okay. This I have written wrong. Why? ये 0 आ गया already, तो उसके नीचे हमको 1 लिखने की जरूरत नहीं है ना? Right, so division galat likha tha maine, just representation of division was wrong. Again I will start writing. So what I am supposed to do here, start writing it properly, correct? So here I will be writing, it's my 1 0 1 and 1, correct? Sorry, little closer, 1, correct? So what we need to do, we need to take that particular 0 down over here, correct? Am I right? Yes, is this clear with all of you?
Yes, ma'am.
ओके, डिवीजन तो सबको आता ही है, करेक्ट? डिवीजन तो मुश्किल नहीं है किसी के लिए भी. यस, so this 0 I will be writing. Fine. So I have written this 0. So now write the answer here. So what will be this 1 1? 1 1 will become 0, correct? 1 0 will become 1. 0 1 will become 1. 0 1 will become 1, correct? Is this clear? Yes, I know this is clear with all of you. Now take this 0 down again. Why it goes off? Okay. We have taken this particular 0 here. Again, take the divisor down. So take this divisor here. Start writing divisor from here. What is the divisor? 1, 0, 1, 1. Correct? This is my divisor. Now 2 times we have taken here. The previous one we forgot to write and the next one. Correct? Now this particular one we have written. Again start writing this. So we will write the answer for this. Correct? So write down the answer. All of you please write down the answer in your notebook as well. So what is 1 1? 1 1 is again 0. What is 1 0? 1 0 is 1. What is 1 1? 0. And what is 1 0? Again 1. Correct? Take this 0 down. The next 0. Just take this 0 down. Correct? I will be writing that 0 here. Oh, why that yes, fine. So I will be writing this particular 0 here. Return the 0. Now take the divisor, right? Take the divisor fast. So we'll write the divisor 1, 0. Oh, again I've made this mistake. I will be writing it from the second position because that 0 is now of no use, correct? So 1, 0, 1 1, correct? 1 0 1 1. Now make this binary division. This is the last binary division, so it is like we need to write this also, so it's 1, correct? So my quotient is 1 1 1 1. Now write this binary division. I'll be writing this division. So what is 1 1? 1 1 is 0. 0 0 is 0. Then 1 1 is again 0. And this 0 1 is 1. Correct? So now as we have added these 3 zeros, correct? How many zeros we have added? Now we'll look into this all part carefully. Fine. I have added 3 zeros. Correct? So this is my data word, this is my divisor, and these 3 zeros are added as redundant bits. Correct? So we will be taking, please remember, please listen to me very carefully. We will be taking last 3 zeros of this remainder, and this is my CRC. Understood all of you? So what is my CRC? This is my CRC. So now my code word will be, correct? Oh, just a second. Now my code word will be, what is my code word? My original data, that is 1 1 0 1, which is appended with the remainder 0 0 1. So this is my code 1, which will be transmitted as TX at TX side, right? So transmitted data is 1 1 0 1 0 0 1. I hope this is clear with all of you. Anybody having any doubt over here in this binary division? Anybody having any doubt? So this is what method we have seen? We have seen the method of CRC, correct? What we have seen? It's a cyclic, it's a cyclic redundancy code, correct? It's a CRC method. Understood? We have taken a data, right? Then we have a divisor. We have added few number of zeros. How many number of zeros? One less than the length of the divisor. And then we simply did a binary division. Whatever remainder we get, so we will be taking the last 3 digits of a remainder, because we have added 3 redundant bits of zeros. So we will be taking 3 digits of the remainder. So my code word is 11010001. So this is my code word. I hope this is clear with all of you. Is there any doubt? Is there any doubt to anyone? Okay. So again, we will share our PPT. Okay. So this is now this is the same method which is explained in PPT also. So CRC checker function exactly like the generator. It's have the data plus CRC divided by the predefined divisor. If remainder is all zeros, then accept, otherwise discard the received data as well. Now how do we decide this divisor? So if we have a polynomial, from this polynomial also we can have the divisor. CRC generator is also represented as algebraic polynomial. It is short. Now we'll see how to represent it. So whatever suffixes we have, like we over here we have 1. So at the 0th position we will having 1. X is also present there. So X is having the coefficient. So 1 for the first position. Then at the second power also we have the coefficient. So we are represented as 1. For X raised to 3, the third power, we don't have a coefficient, right? The coefficient for the third power is 0. So we are writing 0 over here. Coefficient for the fourth power is also 0. So we are writing 0 here. Then coefficient for the fifth power is 1. So 1 is written there. Sixth power is 0. So 0 is written, and seventh power is 1. So this is how we are deciding how to, we are generating a numeric or bitwise divisor from a polynomial. Understood all of you? A bitwise divisor is how it is generated from the polynomial. It is given here. So there are some standard polynomials for CRC 12, CRC 16, CRC 32. So they are given over here. So for example, CRC 12, we have a standard polynomial as x raised to 12 plus x raised to 11 plus x raised to 3 plus x plus 1. So like this, we have the standard polynomial for CRC 16, CRC RTU and CRC 32 also. Now this is the example of CRC we will be taking. Now we will again see. So this is what is the example which I have taken. Not I will say I have taken, but this is also one more example. So in this case we have the divisor as 1011, a data as 1001. We will be appending or augmenting some number of zeros which are equal to 1 less than the divisor. So 3 zeros are added. Then we perform a bitwise division. A complete bitwise division is performed here, and we have received some remainder. So these 3 bits of the remainder, we will be leftmost bit is 0. Use 0 divisors, correct? So we have taken this remainder. That remainder is appended at the end of a data, and then we form a code word. So this particular code word will be transmitted on a transmission line. Understood all of you? Now we will see what happens at the receiver side also. Correct? So over here, data word is 1001. Correct? Fine. So code word is, see, the code word which is received as 100. See, look at here. So it's 10011110. Correct. So 10011110. So this is what the code word I have received. So what I will be doing is, again with the same divisor, right? Again with the same divisor, I am doing a binary division here. With the same divisor, I am performing a binary division here. So this, what is the answer which I have received? I have received the answer as 0 here. Correct. What does it mean? When there is a remainder as a 0, accept the data. Correct. Now suppose while transmitting a data, correct, this is my actual data, but while transmitting a data, a 1 bit is flipped. So this 1 has become 0 over here. So again, see, now at the receiver doesn't know कि क्या change हुआ है transmission के time पे. तो receiver के पास data आया है, right? So receiver is going to divide a data with the divisor. Correct? So again division किया, binary division हुआ आपका, fine. Remainder क्या मिला आपको? Remainder क्या मिला है देखो आपको? Remainder तो आपको 0 नहीं मिला है. Correct? Remainder मिला है क्या आपको 0? नहीं मिला है. Some answer we have received at the remainder, that is 0, 1, 1. So what does it mean is, as I have not received the remainder as a 0, it means that some data had changed while transmitting. Some transmission error has got introduced in the data while transmitting the data from the transmitter to a receiver, and discard the bit. Understood all of you? So we have discarded the bit. So this is what is all about a cyclic redundancy code.